All right, let's take a look at classes of enzymes. And the catalytic behavior of proteins acting as enzymes, so again, an enzyme is nothing more than a protein, is one of the most important functions performed by cellular proteins. Without catalysts, and again, an enzyme is just a catalyst. So without these catalysts, most cellular reactions would take place much too slowly to support life. With the exception of a few recently discovered RNA molecules that catalyze their own reactions, all enzymes are globular proteins. Enzymes are the most efficient of all known catalysts. Some can increase reaction rates by over 1,000 times that of an uncatalyzed reaction. And so you must know the definition of an enzyme, which is a biomolecule. It's essentially a protein, really, that catalyzes a chemical reaction. So again, what does it mean by catalyze? It takes a reaction that would normally be too slow and it makes it much faster. And we're going to talk about how it does that in a later video. Now, enzymes are well suited to their essential roles in living organisms in three major ways. First of all, they have enormous catalytic power. Then they're highly specific in the reactions that they catalyze, and their activity as catalysts can be regulated. And part of the reason enzymes are highly specific in the reactions they catalyze is that they have evolved to be specific for certain substrates. And a substrate, it says here, the definition of a substrate is a substance that undergoes a chemical change catalyzed by an enzyme. Really, a substrate is nothing more than a reactant, okay? Because when you have a substrate that's undergoing a catalyzed, an enzyme catalyzed process, the substrate is really just the starting material, okay? And so the substance that an enzyme acts upon is our substrate, but essentially all it is a starting material, nothing more than that. Now, enzymes act with different levels of specificity from acting on a single specific substrate, and we call that absolute specificity. So when your enzyme can only act on one type of substrate, we say it's absolute. And some examples of absolute specificity of a substrate would be something like urease, which is an enzyme that only acts on urea. So if you've ever smelled a cat's litter box, okay, so what happens is that the cat, puts urine in the litter box, but then urease acts upon the urea and it liberates ammonia and carbon dioxide. And so what you smell is the ammonia. Another example of an absolute or an enzyme, excuse me, with absolute specificity would be sucrase, which acts only on sucrose, which is table sugar. It breaks it down into glucose and fructose. And I'm sure some of you have studied enough biology that you've heard of glucokinase, which acts only on glucose, to transfer a phosphate from ATP to form glucose 6 phosphate or G6P. Anyhow, those are all examples of enzymes that have absolute specificity. Lactase would be another. So lactase acts on lactose, breaks it down into glucose and galactose. Anyhow, that's enough of those. Enzymes are also categorized based on the type of reaction that they catalyzed, many of which are fundamental reactions from organic chemistry that happen to take place in the body. For example, reactions from the previous chapters like oxidation and reduction, alkene addition, hydrolysis are among those found in both organic chemistry and within many enzymes. And so if we just zoom in on the table here, table 12.4, you could probably guess what these enzymes do. So you could probably guess the type of reaction catalyzed just by looking at the group name. So oxidoreductases, right? What are they going to catalyze? Oxidation and reduction. Transferases. If you've ever heard of a kinase, so a kinase, I'll put here kinases are a type of transferase, and they transfer functional groups. A kinase transfers a phosphoryl group, then a hydrolase is going to hydrolyze some kind of bond. A lyase is going to be an enzyme that catalyzes addition of a double bond, or it could be the reverse, could be the formation of a double bond. You guys remember what isomers are, right? Molecules that have different connectivity but the same molecular formula. An isomerase is just going to catalyze some kind of isomerization reaction. And then ligases are involved in the formation of bonds with ATP cleavage.